Okay, another project which is currently in the press, which is called the Muqab in Riyadh, another landmark project in Saudi Arabia. The intention is to build a 400 by 400 by 400 meter cube, a box. It will be the world's biggest building, even bigger as a Pentagon. The idea is that inside this 400 by 400 by 400 meter box building, we're building another building, which is this kind of tower building, which is 330 meter height. Around this interior tower, there's a design or there's a plan to have the world's biggest video projection area. Now, the whole development is the kind of center point of a whole new city development called the Muqab. The project itself, it's also one of these completely new ideas. I mean, in the end, if we talk about sustainability, how can we design a sustainable building, both in hot and cold climates? It starts with very simple things. It starts with the A to V ratio, we call it. So what is the external surface area? So what's the building envelope? For example, if we take this as a box, we have the sides, the top. Yeah, so this is the kind of envelope. And then we have the volume of the building. Yeah, and a building is more efficient the better the A to V value is. For example, the best is a ball, is a circle, a kind of box building. But if you build a flat building, it's usually pretty bad. Yeah, because you need to cool down this interior space. And the less surface area you have, the less facade and roof area you have, the easier it is, because the facades and roof, they have a poor U value. So all of the heat gain or heat loss is through your building envelope. And if you minimize the building envelope area compared to your volume of the building, then it's getting efficient. That's why, actually, this is why, for example, like a single-story building is usually not efficient. You want to put some floors on top, because then you get a kind of box which is more efficient. It's a bit of a similar idea over here. We're creating a massive, massive interior volume, which means we also need to cool it down less because the solar heat gain is less, and also the volume or the surface area or the building envelope where the heat loss takes place or the heat gain takes place is less.